Good morning, geometry. I am recording lesson 11.1, talking about similar figures as we begin chapter 11. Similarity. What is similarity? Well, so for many of you, we'll talk about this in our Zoom meeting as well, but similarity is things that have stuff that is similar. What we will do with similarity is we will use this for us to be able to solve. Now, if you recall what we've learned last chapter, we talked about 5 ways to move something. So in other words, we talked about what? It was our 5 isometry. We had isometries. We talked about dilations. We talked about sliding, translations, rotations, and different things like that. So now what we're talking about in this lesson is similarity. Well, the only one of those things that preserved the shape but did not preserve the size was our dilation. So essentially what we're going to be speaking of in this section is dilation, all about dilation, which is what we're going to talk about in similarity. Now, what did we learn about with the dilation? We learned that there was a scale factor. Well, what was the scale factor? Our scale factor from a dilation, okay, was image over the pre-image. And then we learned that the fraction of that would be smaller, and then as it grew, it would be a whole number, and so therefore it would be bigger. Now, what we're going to talk about in this section to start with similar figures is we're going to start and we're going to be able to compare them and say, hey, they're similar, and how are they similar? So here's the idea. If you have a scale factor, okay, we learned how to do that by using the pre-image over the pre-image. So, for instance, they gave us the first example, and just as a review. If I ask you to find the scale factor of a model car that is 7.08, okay, and the actual Ferrari, which is 14 feet, okay, feet by 8 inches, 8 inches, okay? So, or 9 inches, I'm sorry, 9 inches. So, how would I set this up to find the scale factor? Our model to the actual. So we would put this model, which is 7.808 over 14 and 9. Now, that correct? Any questions there? Now, what would I have to do? In order to actually solve this, I need to convert our feet and inches into one thing. So 14 feet is what? 196, right? No. 14 times 12. What's 14 times 12, class? So we have 8, 2, 0, 4, 1. So 8, 6, 168, right? So 14 times 12 is 168, plus 9, it's going to give us 177. So 7 inches over 177. So if I were to reduce this, what approximately would that be? And if I were to do the math on your calculator, you can use a calculator, you'll get 0.04, which is 4 to the 100th power, approximately 1/25. So my fraction from the scale factor from here to here is 1/25 the size. So my model is 1/25 the size of the actual car. And that's how you would solve it. So you have to make sure, first off, you have to make sure that your numbers are in the same method. Okay, so in other words, inches and inches, not inches and feet. You can't combine inches and feet. You have to combine inches and inches. All right, now, the next part of this lesson, the main part of this lesson is just learning how to compare similarity. So when we talk about comparing similarity, one of the things you'll have to do is what's called proportions. So what is proportions? So proportion. And we all know what a proportion is. Proportion is, or a portion. So like for instance, if we have 6 people in the family, you portion it out 6 ways to be equal. Does that make sense? So you're going to portion part a little bit more to one person than as another. Now, the idea of this is how do we solve proportions? So if I have x over 5 and 10, let's do it this way. How would I find what my portion would be, or how would I find what the proportion is? So it's very simple, very ideal here. X and 50, 5 and 10. So what I'm going to try to do is get x by itself. So I'll do what's called cross multiplication. Cross multiply. And when I cross multiply, I get 10 to the x power equals 5 times 50. Now remember, I told you guys back at the beginning of this class, or in doing this, always, if possible, if you have a fraction, reduce those fractions top and bottom before you cross multiply or do any work. That way you don't have to do any work, because when you cross multiply, all you're really going to do is you're getting rid of this, and it's going to be x is equal to 5 times 5, which is 25. All right, so let's practice on another one. Make one that's not as easily. 2 over y equals 3.5 over 14. All right, so here we go. What do we do first? Cross multiply, right? So if you can reduce here. If not easily, don't worry about it. So cross multiply. 3.5y equals 2 times 14, which is 28. Now, are we done? No, because that's not giving me what y is. I need to find what y is. Divide by 3.5, divide by 3.5. Y equals what? 8. How do I know that? Well, I put it in my calculator in here, but the other way I know that is 3.5. 3.5 times 2 is 7. 7 goes into 8 4 times, so 4 times 2 is 8. And that's how I got my answer. So, you are simply doing your proportion, cross multiplication, and then solving. Now, the last part of this lesson, 7.1, that you need to make sure to have an idea of before we get started and start working on some homework, is how do you compare similar polygons? Or how do you compare polygons? Now, think about that for a second. We've talked about this. If I have 2 polygons, one big and one little, the shape has to still be the same. Do they agree with me? Because the one thing that's preserved in isometry is the shape. So if I have this A, B, C, D, E, F. Now let's think about this for a second. How would I compare these? So we know our angles are going to be equal. What do we know about these sides? These sides are going to be proportional. They're going to be proportional. How do I know which sides will be proportional to which one? So if I were to put 4, 8, and 12, and I said that this was 2 times bigger than this one, which one over here would be 2? Because 2 times you're going to divide by 2. Which one would we talk about? What do we do? DE, EF, DF. Well, we got to look at our 2 angles, 1 and 2, 1 and 2. So this means this one here is going to be 2. AC is going to compare to DF, so therefore that's going to be 4. And BC is going to compare to EF, which is going to be 6. All right? And so what you have to remember is how you're going to compare these 2 shapes to each other. All right? So that's how you would do this in this section here. All right? So you're going to look at the shape, which side goes with which side, compare them, set up the fraction, one over the other, keeping the fractions together, and you'll be able to solve for all of those involved. All right? So that's 7.1. Good luck on the homework. We will go over it together in the class, and then we will start into lesson 7.11.2 soon.